Hey folks, and welcome back to The Startup. I am your imaginary founder, Rob Barnes. Some of you know me as DevOps Rob. And in this series, we are going through the process of building and deploying an application for our imaginary startup and using the HashiCorp stack to deploy it and get the most out of our platforms. Quick recap on where we've gotten to so far. So we've been using quite heavily a tool that we call JumpPad for local development environments. A lot of the focus has been around building local development environments. And, we've done a few things where we've configured that. We've got Nomad running on that. We've built a microservice and got that deployed on Nomad using JumpPad. Then in the last episode, we shifted gears a little bit. We decided to build a microservice which was responsible for cryptography within our application. So it's the crypto service, and we're using Vault and the transit secrets engine in Vault to be able to encrypt and decrypt data. In a previous episode, we went through the process of using the Go SDK to build that, and that was not without event. If you didn't see that, definitely go back and check that one out. That one's super cool. But yeah, so we managed to build that microservice, and today we are going to try and get that deployed to Kubernetes. And, I've done a lot of legwork and a lot of preparation up front, so this shouldn't be as painstaking as some of the previous episodes, because as we do in this show, I am learning just like some of you are learning, right? So this is all me just learning in public, and I don't know it all. We're going to figure it out when we don't know something, right? So we have our microservice, right? In order for this to work on Kubernetes, we're going to need to basically have Vault running. So we use the Vault Helm chart to configure that to run on our Kubernetes cluster. If you remember in previous episodes, how we were able to deploy Nomad to our JumpPad environment is the same way we can deploy Kubernetes to that. So we have a module for that. I can quickly actually even walk you through the code for that as well. Let's do that. So in JumpPad, let's see if we can make this a tad bigger. Let's just clear out my desk a little bit. Can make this a bit bigger. Right, so we have a resource which is Kate's cluster, and we're calling that K3s. I guess it's K3 under the hood. And essentially that is just going to deploy a Kubernetes cluster to our network that we've created, right? So there's nothing really fancy about that. It's just Kubernetes running, right? And if we just, in my terminal, if I run jpm, we should see that we have a kube config, which it has been exported to this location here. I'm not sure if I can actually zoom that up. I don't think I can. So yeah, we've got Kubernetes running. Now it has, on that Kubernetes cluster, it already has Vault installed. I think we can have a quick walkthrough of that code here. We'll just zoom this up a little bit. This is a module that we're using. JumpPad has the concept of modules, pretty much like Terraform does, which are nice building blocks that you can use to build your development environments. And essentially all we're doing here is we are using this module, which is using Helm under the hood and the official HashiCorp Helm chart to deploy our Vault cluster to our Kubernetes cluster. We're also doing some other stuff, so we are creating a script. So we just use this template stanza. We went through all of this in the last episode, so I'm not going to spend too much time on this. We're just creating a template which builds a script which is going to enable the transit secrets engine, because that is a prerequisite for our microservice to be able to function, right? And then, yeah, essentially we're just using a remote exec container to remotely run this script against our Vault cluster. We mount our script to that container so it can actually execute that. And we just give it some environment variables like the token that you need to use to authenticate with Vault, and how to even communicate with Vault. So what's the address? So we have all those things interpolated there. That's pretty much it. Like I say, nothing too fancy going on. So in order for us to be able to perform the functions of cryptography, we are going to need to authenticate to Vault, right? Now, if you remember in the last episode, we didn't actually build authentication into the application code, right? We don't want to do that. That's complicated, and it just you just want some degrees of separation here, right? So what we're going to use is we're going to use the Vault sidecar injector, right? Now, typically, most people think about the Vault sidecar injector as something that helps you get secrets into Kubernetes pods, which is true. You can use it to do that. But you can use it for much more simpler workflows, even when your application needs to be Vault aware. So if you think about our microservice is communicating directly with Vault, and that makes it Vault aware. But we need to authenticate that. And as you know, we don't want to put our Vault token in our source code. That would be bad practice. And also, we have to think about wherever it's getting Vault token from. So let's just say we write it to an environment variable, for example. How is the life cycle of that Vault token going to be managed? When it expires, how are we going to renew that, right? So what we're doing is we're using the Vault sidecar injector pretty much for authentication. And it's going to basically authenticate using a Kubernetes service account. And it's going to exchange that service account attestation for a Vault token, which is going to have our policies associated with it. And the sidecar injector is going to be responsible for not only performing that authentication, but making sure that our Vault token is always up to date, right? So as far as our application is concerned, you just need to tell it where to look to find that Vault token, and it will always be able to communicate with Vault because it will be authenticated, because the Vault sidecar injector will do its job and make sure that you always have a valid token available to use for that microservice. Now, it is a sidecar, so it is just another container living alongside the containers for our application within the same pod. And we'll go through the steps of that, right? But the first thing we need to do in order for this to work is we need to configure our Vault we need to enable the Kubernetes auth method, right? And we need to configure that in order to be able to speak directly to our Kubernetes cluster. So we're just going to get into some code here, right? Let's see if we can make this a little bit bigger. I'll just clear this screen. And yeah, let's get into this, right? So I've already got my jump pad environment up and running. I already have Kubernetes there. It's working. So what we're going to want to do is we're going to want to exec into our pod, right? So if we just quickly just do a Kubernetes get pods, and we'll do -a for all namespaces. And you can see we have this Vault -0 pod here. And that is basically our Vault server. So we're going to want to exec into that pod there, right? So we'll do k exec, and it is Vault -0. And because we want to get into the shell, we'll just do -- and it's bin /sh, and that should get us into the shell of that pod. Oh, no, I forgot. I probably should be doing -it, because that just kind of runs an arbitrary command. So that's our first pebcac of today. And we're in. Let's see. Give ourselves a little yeehaw there. Right, so we're now in, right? So like I said, we want to enable our Kubernetes auth method. So we can do Vault auth enable Kubernetes, right? That should enable it at that mount point. And it does, right? So that's good. Now we need to tell Vault where Kubernetes is, right? How do you talk to Kubernetes, right? And so to do that, we're going to write a Kubernetes config. I've actually got some of these commands here because I didn't trust myself to do this on a not live stream. So I'm just going to copy pasta that into our terminal, and it's run already, and that was a success. We'll just quickly look. So we're writing our config, and we're basically saying the Kubernetes host is at this address, and it's just using this environment variable to essentially just read the Kubernetes address. And yeah, that's pretty much it. If you just want to see what that looks like in practice, I will quickly just echo that so you can see. it's just an IP address. If I do echo and I paste that, and we just get that address 10.43.0.1, right? So that's our Kubernetes address, right? So that's cool. Now, the next thing we need to do is we need to write a role for this, right? So when people authenticate, or when applications, should I say, authenticate to Vault, right? You want them to authenticate using a role so they know what permissions they can get, right? So again, copy pasta, didn't trust myself. We're trying to limit those sounds there. And every time we mess up, we're going to try and run that. So I'll just paste that in here, and it's run successfully, but we'll just have a look at that. So basically what we're saying is that we have a role called crypto, because our microservice is called crypto. And we're binding that role to a service account called crypto-service-account. So that's the only service account that's going to be able to use this role. That is bound to a namespace in Kubernetes called crypto. So again, it must be coming from that namespace. And the policy that is going to be associated with this role is a policy called crypto-policy.htcl. We'll go through all that shortly to actually get that up and running. But essentially, that is our Kubernetes auth method configured, right? So we will just Control D out of this and clear our screen. So that's cool. Now, we want to create that policy. If you remember, there was the policy in there, the crypto-policy.htcl. We want to create that policy, and we'll do it in the UI. Let's do it in the UI. Let's log in to UI. So we're here now, and we'll go to policies. You can see we have no policies here. And we'll create a new ACL policy, which is going to be called crypto-policy.htcl. You don't actually need the .htcl, but I'm doing that because that's what I've got in all my code at the moment. That's fine. And I've actually got the policy here. So we'll just bring this up and let's zoom this up so we can just have a quick look at this, right? So essentially we are giving it update permissions on the path transit encrypt, and the star that you see there, the asterisk, is like a wildcard. So basically what we're saying is that you have update permissions on any key using you have the update permissions to encrypt using any key, right? Now the reason for that is, remember, the goal is that every single user will, when they sign up, have a cryptographic key assigned to them. So for us to sit there and create a policy which has every single named key is just not sustainable. So we can just use this pattern matching and just put that asterisk there as a wildcard. So every key, we will be able to perform encryption functions with that. We can also do the same with decrypt. So it's exactly the same, just it says decrypt instead of encrypt, right? And you can see that from line 9. And lastly, we want to enable key management, right? So this microservice needs to be able to manage the lifecycle of keys. It needs to be able to create them, update them. It needs to be able to delete them as well, right? So we're basically saying that on the transit keys path, you can manage any keys with these permissions here, right? So simple enough policy, nothing too stringent. We'll just copy that and we're going to paste it inside our UI here. So we have key management, we have decryption, and we have encryption. And that is our policy created, right? So that's fantastic. So we've got our Kubernetes auth method configured. We now have our policy configured. Now we need to create a namespace in Kubernetes. If you remember, our role was saying that it's bound to a specific namespace. So we need to create that namespace in order to do that, right? So if we just head over to, where are we? I have this empty YAML file here. We're going to create a namespace, right? So just hit namespace. And that namespace is called crypto, right? So if you're familiar with Kubernetes, this is just a Kubernetes manifest file. We're using YAML, as you do. You need a PhD in YAML for this stuff, and you can call me the Dr. Founder. So yeah, we have this, and we just need to apply that, and that should create our crypto namespace, because this is the namespace that our application is going to run within, right? So we'll just save that, and in our terminal, we'll just do Kubernetes apply, and we just want to give it the file, which is located at Kubernetes and crypto.yaml, right? If we hit enter on that, that has now created our namespace. Let's just have a quick look at that. So if I do get namespace, if I can spell, let's give ourselves a yeehaw. There we go, get namespace, that should be good. And you can see we have our crypto namespace, which has been active for the best part of 16 seconds, probably longer now. Cool. So let's clear our screen there. Now, our application is running obviously in a Docker container. If we're using Kubernetes, it has to be in a Docker container. And in order for that to work, we're going to, that Docker container is actually stored in a Docker registry, which is private. The image is private, and we cannot pull that unless we give it a Docker secret. So we're going to need to write that secret. But before I do, I can see my camera is on some stuff. So let me just sort out a setting on my camera before it starts doing things that I do not intend it to do. Yes, I'll just switch that off. Fantastic. My camera is an AI camera, so it looks at hand gestures, and me just gesturing as I was speaking, it switched on auto tracking, which will make the camera move as my face moves. And we don't want that because I have a nice, beautiful green screen behind me. But anyway, we now want to create our secret, right? And we want to create that secret in our crypto namespace, right? So we have this command that we're going to run here, and we'll just walk through it, right? So we're creating a secret, and that secret is called Docker Hub, right? It's a special type of secret. It's a Docker registry secret. And we are giving it a few things. So we're giving it Docker server, which is docker.io, as you'd expect. And we're giving it our Docker username, which I've actually put these down as Terraform variables because later on in this video, potentially in the next video, we'll see how we get on with time. We are going to Terraform this whole process, right? So just to make life easy, I've put this as environment variables, and it's Terraform specific ones, so Terraform can pick this up as well. So we have our username, our password, and our email, and we want to write that to our crypto namespace, right? So that's pretty straightforward. We just hit enter on that, and that has now created our secret. So this is going to allow us to pull that image because we're now authenticated with Docker Hub, which is fantastic. Next, what we want to do is we want to create the service account. Again, let's go back to when we created the Kubernetes auth method. It was bound to a namespace, which we've just created, and then it was bound to a specific service account, right? And that service account was, I think it was crypto-service-account, right? So let's do that. Let's create our service account. So we'll just hit enter here, and YAML's a bit fussy about spaces, so I'm trying to be careful. And for service account, like I said, I've done a lot of this legwork up front. So we have a service account here, and we're creating that in our crypto namespace. And the service account, like I said, is crypto-service-account, right? So do the same thing. We'll save that, and we'll apply this manifest, right? So the namespace is already applied. It will just create this service account in this namespace for us. So we just hit that. And you can see namespace is unchanged because we haven't done anything to that. But the service account has now been created, which is fantastic, right? Coolio. So next thing I'm going to want to walk you through is, so our application, if you remember in the last episode, we were doing a couple of things. Let's just go to the source code and we'll delve into it, right? So if we head over to source and we go to main.go, let's take a look. I will make this bigger as soon as I found the point that I'm trying to get to, which is here. We'll just zoom up the size of that. Fantastic. So in order for this microservice to work, we need to give it the vault address, right? And how we do that is we give it an environment variable, which is vault_adder. And you can see here that it's just using the OS package to get that environment variable in Go. Now, the next thing, this is actually refactored. We were doing exactly the same thing that we do for vault address for vault token, right? So we were using the os.getEnv and it was vault_token. But like I said, we are going to be using the vault sidecar injector. We want something that's not only going to give our application the vault token, but it's also going to manage the life cycle of our application. So how the vault sidecar injector works is it will write the token to this shared volume, right? So and it will be shared to all the containers within that specific pod, right? So it's going to write it to vault/secrets/token, right? And this is where our application needs to pick it up from. So I have refactored this application to, instead of using this neat little trick here, we now use this. So we're going to read the contents of that file, and yeah, that's how we're going to authenticate. And obviously, if for some reason or another that file doesn't exist or the token's not in there, something's gone wrong, it would just throw up this warning. It should actually be an error, but I think I've left it as warning because I was troubleshooting some stuff, right? And yeah, as you can see, as you do, you put stuff in logs when you're troubleshooting where things aren't working. Yeah, and that's it. And obviously, when we create our Vault client, we give it the Vault address, and then we give it the Vault token, which we have to convert that to a string in order for that to work. So it's nothing too fancy, really. But on that, like I say, we need to give it the Vault address, and we're going to pass it in via an environment variable, right? So we are going to need to create a config map in Kubernetes, which is going to pass that environment variable to our containers, right? So let's head back to our manifest, and let's just make this bigger. I just realized I've been doing this in quite a small size, so we'll just make it bigger, and we'll just do the 3 dashes again because we're YAML doctors, and config map, right? So we have this config map here, and this config map is created in the crypto namespace that we created earlier on, and we're giving it that Vault adder address. And what we're using for the actual Vault adder address is Kubernetes built-in service discovery, right? So this is the endpoint here. So it's vault.default.service.cluster.local, and then you're giving it the port, right? And that is how we're going to be able to communicate directly with Vault. So that's the environment variable we need to set for our application. So same thing again, we'll save that. We'll just clear my terminal because it's getting a bit busy in there. And we will apply this manifest. And you can see the first 2 are unchanged, and it's now created our config map, right? So that is all good. Now, this is where we get to the juice of it. We now want to create our deployment, right? And deployment is interesting because this is how we're going to specify the specifics of our sidecar injector, right? Let's just get into it and have a bit of a walkthrough on the important bits of this, right? So we'll just put our 3 dashes in here, and we'll just get up a deployment, and we'll have a look at that, right? So here is our Kubernetes deployment, right? So it's called crypto deployment in the crypto namespace, and we're just giving it the labels that we require for the selectors and so on and so forth. But where it gets interesting is these annotations here, right? So within our template for our deployment, we have to set a few annotations, right? So this first annotation is agent inject. And basically what that is saying is that, yes, you should have a Vault sidecar injector running within this pod, right? You should have a sidecar and it should run. The next annotation is agent inject token, which is true. Basically, what that is saying is that the Vault token that the sidecar injector gets, should it share it with the rest of the containers within that same pod. And because we need our application to be able to access that token in order to communicate directly with Vault, we need to set that to true, right? Now, the next annotation here is agent init first, which is basically saying, is it going to sort of perform as an init container, essentially? Is it going to start up first before our application container starts up? And again, the answer is yes, it is, right? Because our application has a dependency on that Vault token being in place in order for it to work. So we let that sidecar injector fire up first, and then our application container can then fire up, right? Next, we're telling it the role that we want to authenticate with, which is the crypto role. You can remember when we were creating the Kubernetes auth method and configuring that, the role that we created as part of that process, the final step in that process, was a role called crypto. So that's the role that we're going to auth with. And this is where it gets kind of interesting, at least for me anyway, right? We have this cache enabled, right? So essentially what's going to happen is it allows our sidecar injector to store secrets in like a cache, right? And it kind of saves on like having to always request the secrets, right? So it can cache those things there, and it just makes life a bit easier, right? But by enabling that cache, we can create this next annotation, which is auto auth token. So essentially what that's doing is it's always going to make sure that the token that the sidecar container gets is always a valid token. And obviously when it's reached, I think it's when it hits 2/3 of its life cycle, it will automatically renew that and write the new token to the shared volume, right? So the applications can just use that when it needs to. So that's super cool, right? That's pretty much like the important part of what we have going on here, right? So we have all of these annotations, and then the rest of it is just standard stuff. Here is the image pool secrets. This is the Kubernetes secret that we created before. That's going to allow us to be able to pull our Docker image, our private Docker image from our registry. And then we just have some container definitions here. So we want it to always pull a new one. We have the name of our container image, and we're basically sourcing our environment variables from this config map here, which is the one we created in the previous step, and we're just giving it some port information. So yeah, it's kind of standard stuff, but it's just the annotations that makes this thing super cool, right? And we'll do a bit of messing around and delve into that, but I think what we want to do is we want to save this and we want to apply this so that we can get our deployment up and running, right? So we have our deployment here, right? So that's fantastic. And let's just have a quick poke around and see. So if we do Kubernetes get pods, and we'll do -A because we want all namespaces. And you can see at the bottom, we have this crypto namespace, and we have our pod, which is coming from the deployment, and you have 2 out of 2 containers. And basically the 2 containers are, one is the application container, the other is the Vault sidecar injector container that's running next to it, right? We can actually even exec into that and just have a quick nose around to see, can we actually see a Vault token has been created? Obviously it has, because we would have a failure if it didn't, but just through the way that I've written the application, it should fail if the token's not there. But if we do k exec, and then we do -n for namespace, and it's crypto, and we're not going to make the same mistake as last time, so we do -it, and we want to exec into that container there, and again it's going to be /bin/sh, and that should get us into our container, and it does. And in here, if I just do a cat, and the volume is Vault, and it's secret and token, if I cat that, we should have a Vault token inside there, and we do, right? So that's the sidecar injector working its magic. It's sharing the token. It's used its Kubernetes service account that's that's in the pod, or assigned to the pod, and it's used that to authenticate to Vault. And Vault in return says, okay, we can confirm that you are who you say you are. Here's a Vault token with the policies that the role defines, right? And this is the Vault token here. Right. And if you remember, if we actually mess around a little bit, let's actually copy this token. We'll just copy that. And if we just log out of this and log in, we should hopefully be able to test out some stuff and just see. We should at least see that we have the transit secrets engine. Right. And we can see that, but we're getting a not authorized because I haven't put any list permissions for like different things within that. But, you know, that goes to show that it's working. So we'll just log out of that. Right? So we'll sign out here and we'll log in with our root token. And now you can actually see stuff. So in this transit sequence engine, as you can see, all we've done is that we've enabled the sequence engine, right? So let's just come out of this and we'll clear our terminal again. Now, we want to be able to test out our microservice, right? We want to run some API calls against that microservice. In order to do that, we're going to need to create a Kubernetes service, which is going to expose that to us, right? So the legendary 3 dashes, YAML, and we're just going to create this service here, right? Which is called crypto service. And again, the app selector is crypto because that's the same label that we've used for our deployment. And we're just giving it some details like the port, and the type is node port. That's just how we're going to do it, just for this sake. I think in the grand scheme of things, we probably are not going to expose it like this going forward, but this is just for us to be able to demonstrate and test that our application is in fact working, right? So we'll hit save on that, and we'll apply this manifest. And we now have our service has been created, right? Now, we should be able to test this, and I think we can actually test this. If I just go to our jump pad configuration, I'm going to show you something, right? So we want to expose this port, just at least to my local machine. So jump pad has ingress. I think we've spoken about this in our previous episode. So what we're doing here is we're having to create this resource in jump pad. I think I've already done this. So if it doesn't work, that means I haven't, and we'll run this again, but it should be fine. Essentially, we're saying that the ingress is port 2002, and the target is our Kubernetes cluster, which I've showed you earlier on. Let's make this bigger actually, because I just realized it's tiny sized. So our target is this Kubernetes cluster. The port again within that Kubernetes cluster is 2002. And the configuration for it is we're telling it the service is the crypto service. That's the one we've just created. And that service can be found in the crypto namespace, right? So all of that should allow us to test our microservice. And so what we're going to do is we're just going to curl localhost port 2002. And hopefully it works. If it doesn't, then that means I need to run this because I thought I have run it before. But we'll just curl that. And yeah, it does work. So that means we do have ingress into our microservice, which is fantastic, right? So let's test out the microservice, right? Let's create a cryptographic key, which I'll just copy paste to this. So remember, this is on the right is the transit sequence engine here. There are no keys inside here. So if this works, our microservice should be creating a new key called test, right? So you can see key name test, and we're just hitting the endpoint, which is create-key. It's a post API call, nothing special. Let's hit enter on that. And no news is good news. So because it's just like a 201 response. So if I go back and I hit secrets, you now have this key. So where's my round of applause? I feel like I deserve a round of applause because it worked. Listen, it's noisy. So, gotta be your own biggest cheerleader, celebrate them wins. Anyway, we have our cryptographic key. So the next test we're gonna run, just clear that, is we want to encrypt some data, right? Again, we'll copy pasta that. And we'll paste it in here. Let's have a quick look at this, right? So we're doing batch encryption. Like the way this microservice is set up is to do batch encryption. So for each user, there are a few things that need to be encrypted. And rather than making several calls to Vault to encrypt each individual bit, what we do is we have it in an ordered list, and we send that one list for batch encryption, and then it will come back with the batch results, right? So the first one we're encrypting is first name. Second thing is surname. Third thing is mobile number. And the fourth thing is a date of birth, right? except for my name, all totally made up, right? So if you're going to try and do anything fancy and fraudulent with those details there, be my guest. It's not going to work because that is not my phone number and that is not my date of birth. Not even close. Right. Let's hit enter on this. And if this works, we're going to give ourselves another pat on the back, round of applause. You know how it goes. We'll hit enter and cha. Round of applause. Love it. So we have our batch results. We have this ciphertext here. And I can't remember if I explained how this works, right? So basically, a ciphertext starts with Vault. So it shows you that Vault is the thing that's performing the cryptography. It's then followed with a V1, which is the version of the cryptographic key, right? We only have one version of it. If we were to rotate the key, it would create version 2. So this is encrypted using version 1 of that key, right? If we create version 2 of the key, it means we can still decrypt this data because version 1 is still there. We can talk a little bit about how that piece works, maybe in a future episode. We could deep dive into that. If that's what you want, leave a comment leave a comment below the video and we'll make a separate video for that. And then after the V1, it's just basically cybertext, which is the gibberish that you get, the scrambled up ciphertext, which is based on the cryptographic key that we have used to encrypt it, right? So let's create a new Scratch file because we're going to want to test the decrypt function. So I'll just create a Scratch file, just make it a shell script, right? And I'm going to copy past something else. If I can actually find where I've put this Scratch file, I think it's potentially this one here. So we'll just copy this, just put it into our new Scratch file here, because we're going to want to do a little bit of refactoring here, right? So we have this first piece. There's 4 pieces of ciphertext that have come back. So we just want to copy and paste each of these into this payload here, just so it can decrypt them, basically, or we can at least test the decryption, right? So that's 1 down and 3 to go. We'll make light work of this. So we'll just move over to this second one here, which you can see when I was testing before, we rotated keys and we got to 3 versions of it. I think actually in a previous video, I had rotation as part of this microservice. I've since changed my mind and decided that rotation should be its own service. I'll explain that in a future video because I'm probably going to make that microservice on one of these videos as well. So we just got the third one here. Copy past to that. There we go. So we'll just overwrite that. Hopefully I haven't screwed up any copy and paste. And then we've got our final one, because watching me copy pasta is much better than watching paint dry. So I'm told anyway. Let's do that. And we'll paste in here. So that's our API call, right? Our API call is a put request with that payload that we just refactored, and we hit on the decrypt endpoint, and then we're just passing it a query string, which is the key name equals test, right? And we shall just copy that and we'll paste it. I'll just clear my screen and paste that in there. And that should give us our plain text back, which is fantastic. So in the microservice, that's what happens. Let me explain this. Furthermore, where's my round of applause? I'm proud of us, man. We did it. Anyway, the way the transit engine works is you need to give it plain, when it comes to encryption, you need to give it plain text, but that plain text, well, you don't need to give it plain text specifically. You can actually encrypt almost anything you want, but the payload you give it to encrypt needs to be base 64 encoded, right? So the way that I've built the microservice is when you give it plain text, when you give it a string, for example, it will base 64 encode it before it sends it off to a transit engine for encryption, right? Equally, when you decrypt data, it will decrypt it, and what it gives back to you is base 64 encoded plain text, right? And And then normally what you do is you'd go through the process of decoding it, sorry. So what I've done in a microservice is I've built the decoding directly into the microservice so that it just gives us the plain text back. So you can see the batch results just goes in exactly as we gave the original payload, right? And that is super, super, super cool. Now, the next thing we really want to do here is we gonna want to create all of this using Terraform. Now, that might take a while, so I'm gonna call it there. We're gonna call that an episode, and we're gonna come back in the next episode and we're gonna mess around with Terraform. We're gonna take everything we've done and create that Terraform configuration for that, instead of messing around with our YAML manifest that I now have a PhD in. Shout out to Armon for that PhD crack, because that's his joke. I heard him say it at a conference somewhere. But yeah, that's been it. Thank you so much for rocking with me. It's been a load of fun, and we'll catch you in the next episode. Peace out.